Hi there, I am Kim Llanos, and this is my final presentation for CIT 260. I'm going to start out talking about variables. There are static variables and there are non-static variables. Non-statics are instances. Static variables belong to classes, or they're associated with classes, not with objects. It only has one instance per class, and they're created when the program starts and they're destroyed when the program ends. So they're directly accessed by the class name, i.e. class name dot variable name. It's global when it's set to public, which means that it can be shared and accessed without having to create an object of its class. Static variables are constants which do not change from their initial values. And constant variables are declared as public, private, final, and static. And non-static variables belong to objects, not classes, and are instances of a variable. And they don't need to be defined with the keyword like a static variable would be. This is an example of a static variable, the savePlayer function, which passes the string value of the player's name. As you can see, the player's name cannot be null because it's going to throw an exception and then bring up this this player's name cannot be empty message to you. So have to have a player's name when creating or saving a player. So here you can see where the static function savePlayer is called and the player's name is passed through based on the inputs to the console by the player. And this is in the Start Program Viewer. This is an example of a non-static variable, and this is the method go hunting, which is called when the actual menu option is chosen, and this is in the daily trail stop scene menu. Next, I'm going to talk about arrays, array lists, and enums. So arrays, array lists, and enums have a lot in common, but they do have differences. The things in common that arrays, array lists, and enums have are that they can all be referenced by an index. Arrays and array lists can be objects or primitive values, but an enum has to convert to a primitive. Arrays and enums have fixed lengths, but array lists have dynamic lengths. Arrays and enums have the same data type, or have to have the same data type, and array lists do not. They can have different data types. And arrays and enums, their items can be changed, but in an array list, the items are constant. They never change. And arrays require specific syntax, those brackets, and array lists and enums do not. Here's an example of a syntax of an int array with 4 elements and a string array with the same 4 elements. And you can see that there's only 3 that are declared because we know that the index always in an array always starts at 0. And then here's an array list that's a string. There's the syntax for that. And then an example of an enum, which are really, really cool. We love enums. Here's an example of an array list, the characters. And we kind of split up. Characters was kind of an odd duck because we made an array list for characters that has some of the attributes connected to the character, and then we also made an enum called character definitions that also is related to the character. So the character definitions has the name, the availability, the health, and the food. So more about that later. And here it is. Here's the enum example. So here's my character definitions of all the players that we have. And we kind of did the Trekkie theme, as you can see. And we do call this character definitions quite a bit throughout the code. But basically the character definitions has the name, the stamina, their hunting skill, and their gathering skill. So some really interesting things along with their name. Here's an example of a location array, and as you can see, there's 82 locations in my location array that the map utilizes. Next is loops. So there's two kinds of loops, a for loop and a for each loop. So a for loop iterates through an array or an array list, the items or the values, and it repeats for a specific number of times based upon the length of the array or the array list. It's really a succinct way of writing a loop to collect data about the loop, and it could be used for searching, updating array and array list items, and for sorting. And there's the syntax for that. The for each statement is very similar to the for statement, and it starts the same way as the for statement, and it is another way of iterating through an array or an array list. Here's an example of a for loop where the create locations method is used, and you can see that there's an array of locations and they're set at specific locations along the map. So whenever you call that up according to the location type of town, fort, landmark, or river, they're going to be associated to those specific locations. Here is an example of a for each statement, and this is the one that threw me the most. I have the hardest time getting my brain around the for each. So this is in the map control, and it's looking at the list locations method. So like I said, the for each is another way of traversing through the loop. And you can do the for loop, the while loop, the do while loop, and it starts with the keyword for, like the normal for loop. And instead of declaring and initializing a loop counter variable, you declare the variable that is the same type as the base type of the array. And then you follow it by a colon, which is then followed by the array name. So you can see location current and its locations, which is the actual array name. And the loop body, you can use the loop variable you created rather than using an indexed array element. So for each is commonly used to iterate again over an array or a collections class like an array list. Exception handling. This is one of my favorite, the runtime errors. You got the throw, catch, and propagate. So exception handling is important for many reasons, but the two most important reasons are, they're going to tell you where and when there's an issue with the code, like any grammar or spelling errors, or if you forget a semicolon, which I did over and over and over again. Basically they tell you if there's a logic error, like when you need to enter a value at the beginning of the game, you have to enter the player's name, or you can't even start the game if you don't do that. And then there's three parts to the exception handling: the throw, try, and the catch. You throw in the view layer, and you catch. Okay, I got that backwards. You actually throw in the control layer, and you catch in the view layer. And of course, catch statements are always accompanied by the try first. So first you throw it, and then you try, and then you catch it. So this example is in the team control, and we actually throw a lot of errors here. But one of them is you can't hunt if there aren't any animals in the area, or if you don't have a sufficient skill level. You really can't. So it's thrown here in the control layer. And here you can see in the view layer is the try catch statement. So if there's no errors, then you can go ahead and hunt. And what I did here to set the number of animals in the area and the team skill was I made a random class, and I did a range of animals. There's anywhere from 2 to 8 animals in the area, and there's anywhere from 3 to 6 animals in the area. And anything outside of those boundaries would also throw an error. Next I'm going to talk about streams. So character streams versus byte streams. And streams are basically sequences of data. You know, there are two streams that we use in Java. Input streams, which are used to read data from a source, and output streams, which are used to write data to a specific destination. So what are the differences? Byte streams can input-output 8-bit bytes, and they can only read the data 1 byte at a time. Byte streams can read and write in ASCII, but not in text. And a byte file stream reads and writes binary data in sequential order. So character streams, they have an input-output of 16-bit and Unicode. So they're useful for text files and for reading Unicode characters. They can read and write data no matter what the format is, including ASCII. So we use streams to, among other things, output data to an external file, and that could be the code itself, like the whole game itself, or maybe just a report. The steps to writing to an external file are, you know, we need to know what the content is for the file, and that's created within the code using a file stream that connects to the physical location of where the file will reside, like My Documents on your C drive on your PC. The file creation itself, where in the code is the data being read and written to the external file. And then we have to close the stream and never ever cross the streams. So here we have an example of writing to an external file, and this is in the game menu view. And when you choose the menu selection of writing a report or printing a report of the team's wagon and oxen, that is going to pull up or call the team wagon ox view, which is going to actually use the file path of whatever input the user puts in at the console, and that's where the actual file will reside on your PC. So once you've chosen what file path you want your file to be, the next thing it's going to do is it's going to actually run the print wagon ox report method, and this is in the team control. And there's some interesting things going on here. You can see that there's some errors being thrown here. So in order to print the team wagon ox report without an error, you have to have a team, so the team can't be null. You have to have a wagon, the wagon can't be null, and you have to have some ox, the ox cannot be null. And then you have in your the try catch, this is actually the meat of the report. You've got your report heading and the report columns, and you've got the column names, and then you actually have what methods are being called for the actual report data. And here's an example of my team, wagon, and oxen information report. And you can see that this is in my My Documents folder. Lots of reports there. Next is the fun part. I'm going to run the code. Okay, here we go. Enter my name in here. And I'm going to start a new game. Have to buy a wagon. I'm going to buy a large and a large set of oxen. And the next thing I want to do is maybe I want to set the team pace. I'm going to set that to average. Not too slow, not too fast. I'm going to go back to the main menu. And maybe I want to see where's my locations, or where's my, I know what, I need help. So there's my help, and let's see some game tips. Awesome, awesome, awesome. I'm going to exit back here. And maybe I want to go to the trail stop. Let's hunt, and let's gather. And then I'm going to be able to see how much actually goes into my wagon. Well, that went by so fast, but basically I hunted, and I retained 45 pounds of hunted animals that's going to go into my wagon. I might want to see that, so I'm going to print a report. And I'm going to call it Today's Great Haul. And that'll save. And I'm going to exit back to the main menu. I think that's enough for one day, so I'm going to save my game. I'm going to call this Kim's Game. And then I'm going to exit. That's it, folks. Thanks so much for watching. Bye.